Hello guys, welcome to feeding.net. So in this particular session we are going to talk about encryption and decryption in C#. So without wasting time, let's start the session. So for my demo, I have already written the code just to save the time. So here I have created a variable that is original text, and here I am passing hello world. So this is the text which we are going to encrypt, and after that we are also going to decrypt as well. So what is encryption and decryption? So encryption is the process, as I have already written, it's a process to transform plain text. So this is the plain text hello world, which is unencrypted data, plain text into keeper text. Keeper text is nothing but the encrypted data, and this process is called the encryption process. And same for the decryption process. We will take that encrypted data and we convert back that data to plain text, that is the original text. And for that process we need a key. So the same key is used to convert a plain text into keeper text, and that same key will be used to convert again the keeper text to plain text. So here in .NET Core 6.0 version, I have used their library system.security.cryptography, and at the start we need the byte array of key. So here I have generated a key. So for generating the key, I am using a random method. What this method is doing, you are just passing the length, like how much length of byte array you need, and it will use the C# class random number generator, and it will generate a number and it will convert those numbers into their respective byte array. So here we are getting a random byte array for the key. As I told, we need key to convert plain text into encrypted data. Now here we have also using one more thing, that is the IV. So IV, it's nothing but it's basically a random value. So IV also we are generating using the same method. But why we need this? Suppose two person trying to encrypt the same original text. Like I am also trying to convert hello world into some encrypted data, and you are also trying to convert. And if we both have the same key, then in that case keeper text will be same. Suppose this is the hello world, I am person P1. So suppose after encryption it will become AABBBB. And if we are using the same key, if we both are using the same key, so if P2 is also trying to convert this hello world and if we are using the same key, so then that result will be the same. So to differentiate both result, we need and IV. It is also kind of a key, but it's just basically a random key. So here I have written it is a random value used for encryption process. It is handles a case where multiple identical plain text is getting encrypted. Okay, so that plain text with same key produce different keeper text. Okay, so that's done. Now I have passed that original text to a method called encrypt, and I have passed the byte array key and byte array IV. So here this is the method. What it is doing, he is using the AES class of .NET Core, which is called Advanced Encryption Standard. So this is provided by .NET Core, and you have called its create method, and there you used a method of interface crypto transform. There you passed the key which is the byte array that we got in this method, and you pass the IV. So here you can see IV is nothing but the initialization vector that is used for the symmetric algorithm. Then you pass the key, you pass the IV. Now you create the memory stream object, then you create the crypto stream object. There you pass the memory stream, and then you pass the crypto object there. and you tell them, okay, it's a write operation. Now you create an object of stream writer. There you passed your plain text, that is hello world, and what it does, it encrypt your hello world into some uh, a keeper text, like it convert into like something like that, and then we convert that into the base 60 form string, which is nothing but an array of 8-bit unsigned integer that is equivalent to string representation. So we did it, and it returns the keeper text. So this method will return the keeper text. Now we have the keeper text here, and then what we want, like from this hello world we created the keeper text like this, and then again we want to decrypt it. We will pass this, and we will pass the key, and it will again become the hello world. So this is called the decrypt method. So that is the decrypt method. Again we pass the encrypted text, that is this, and then key and IV. So almost everything remains same. So at first step, what we does, the encrypted text, we get the byte array of that using the from base 64 method. Then again all those same object, and then what we did, we called stream writer read to end method basically to decrypt, and here we pass the key, IV, same memory string, crypto, again the same. Here we gave is the read operation, not the write. So I mean that is done. If you can let's run this program for you. So okay, let's just run it right away. So this is the hello world. What it create the key, see, 6 byte array, that is the key, and that is the random IV. Now we went to the encrypted method. See what it is doing, it is setting the keys. It called the crypto encryptor, and it is using some algorithm. And now if we try to write it, let's check here. Okay, everything seems good. Now if we return, see, it returns the encrypted form of hello world. So this is the encrypted form of hello world. Now what we want to convert this back to hello world, so that is the decrypt. Now we went to decrypt, we convert that encrypted text into the byte array because that is what required by memory stream. Now again same decrypt method. Previously I think it was encryptor, right? So just opposite of that, instead of write we need read, and here also it returns you the decrypt. So see, it's a hello world. So if you go to the encrypted text is this and decrypt is this, and we know that original text was this. So guys, I hope you liked my video. So if you like it, then please subscribe to my channel.